factoring polynomials completely. And if you're like, haven't we been factoring polynomials completely? Well, we've been factoring binomials and trinomials, but check this out. This is a polynomial because it has 4 terms. And so actually, they're going to tell you how to do each one. It's going to be by grouping. So if you're like, oh, haven't we been doing that? Yes. But the difference here is that when you see 4 terms, a light should go off. I'm going to try and draw a light real fast. That was such a bad light. That's a light bulb, okay? Oh, gosh. I'm just going to erase it. All right, moving on. If you have 4 terms, you're just essentially going to do this almost immediately and go, hey, does this first term have anything in common? And yes, it has y squared in common. So what's going to be inside of there is y minus 9. And then, oh, look, this has y minus 9. In fact, it has just one of those. So this is where it's kind of funky. We're going to do like this. Plus 1. 1 what? 1 y minus 9. That's a 9 right there. And now we can factor out the group y minus 9, this entire group, this entire group. They both have a y minus 9 in common. And then what's going to be left behind is the y squared from right there and the plus 1. That's the first one. Number 2, factoring by grouping. Well, on this one, we can actually combine like terms first. Oh, just kidding. My brain saw 3s squared and 2s cubed, and it interpreted them as the same thing. So instead of them being the same thing, let's put this in standard form because it's not in standard form. So 2s cubed plus 3s squared plus 18s plus 27. Now we can factor this by grouping. So this group has an s squared in common, 2s plus 3. And again, if this is going to factor by grouping, this and this should end up being identical, and they will once I factor out a 9. So what will be left behind is 2s plus 3. And now notice that there is 2s plus 3 in each group, and what's left behind is s squared plus 9. Done. Now before I go on, let me see if we had to rearrange this, because this next problem, it's not in standard form. Not really, because usually we try and go in alphabetical order, and this one's not in standard form. So I'm just curious if I were to look at this. So like the first 2 terms, they don't have anything in common. These two have 3s in common, so like 6 plus s. Yeah, so we would have to have written this in standard form. But this one, as I look at it, these two have a q in common, so that's q plus 1. These two have 5p in common, so again, we get q plus 1. And then when you factor out the q plus 1, you get q plus 5p. So that's the answer for this one. I'm curious as to why this one didn't have to be in standard form. How I would have written it in standard form, because it goes LMNOPQRS. I mean, you get alphabetical order. So I think it would have been written... You know what, maybe that counts just because, since the q is squared, it's got the highest degree, so q, 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 and then the p terms. Interesting. Factor this one by grouping. Again, so this kind of goes opposite of what just happened up here because, well, maybe not opposite, but in a different way. Because check it out, this has a b, and this has an AB, so here, I'm going to do it 2 ways. I'm going to do it the way it's written right now. So the way it's written right now, the first set has 2 in common, so it'd be a squared minus 6b. Yeah, so this one doesn't work. You have to rearrange it. So I guess maybe they're challenging you to think, hey, is this the right order? So here's how I would have written it to be more in standard form. 2a squared minus 3a plus 8ab minus 12b. And again, that's because of alphabetical order. Highest degree, A and then B, and then just B. So, and if you're like, you didn't finish this one right here, I mean, I could technically finish it. There's an A in common, and then that would be 8B minus 3. And notice how this and this are not the same, so that's why that didn't work, right? All right, so this one, factor out the A, we get 2A minus 3. Factor out a 4B, and we get 2a minus 3. So the answer for number 4 is 2a minus 3 times a plus 4b. That's a B, I promise. B right there. That's our answer. Okay, this is a difference of squares. Now, how they handle it, it would appear is they are going to take out a 4 first. But how I know it's a difference of squares is that's a squared term, that's a squared term, that's a squared term, that's a squared term. So I really, 6a squared minus 2, hold up. Yeah, that times 6a squared plus 2a. That works, right? Because when I distribute 6a, that's 36a4 plus 12a cubed minus 12a cubed minus 4a squared. So this works, but notice that's not one of our answer choices. So what should we do? Let's go back and take out the greatest common factor. In fact, I've mentioned this in class that that's a common trap that we fall into of that, hey, listen, your best starting idea is probably to factor out whatever they have in common. So they have a 4a squared in common. So that would leave us 9a squared minus 1. And that's this one, but notice it says completely. So again, this is still difference of squares. So we're going to have 4a squared, and then this is 3a plus 1, 3a minus 1. If you don't believe me, you can FOIL it and figure it out. It is that one. Factor this one completely. This is just either regular old factoring or it's going to be unfactorable. And when I say regular old factoring, I mean like negative 35, ticket 5. So the factors of 35 are, well, there's 35 and 1. There is 5 and 7. Are there any others? I don't think so. So yeah, this one's just unfactorable because 5 and 7 will never give us 5. 1 and 35 will never give us 5. So we're good on number 6. Factor this one completely. They all have a 3D in common. So here's something fun. Bad answer, bad answer. Possible, possible, possible. Okay. So if I factor out a 3D, in fact, I'm going to take a Q from that and a Q from, I just don't love a negative out front. I'm going to factor out a negative 3D, and I get positive 5D squared minus 7D plus 2. And now we can try factoring this further. 5 times 2 is 10, and that's negative 7. We could have negative 5 and negative 2. Sounds like that's a winner. So we have negative 3D. Zoom out just to have everything come on the screen at once. And we have 5D squared minus 5D minus 2D plus 2. Negative 3D is still out front. This is going to be 5D times D minus 1 minus 2, which is going to be D minus 1. All right, so negative 3D still out front. D minus 1, 5D minus 2. Okie dokie. It is this one. They've all got a 5w squared in common, so w squared minus 8w plus, let's see, 80, that is 16, I believe. And can that factor? Let's see, 16 and 8. Let's see, 8 times, no, 16 is got to be 4 and 4, right? Both negative 4s. So we're going to have 5w squared, w minus 4 squared. Let's see, that's this one. I was about to check this one, but it's that w squared, right? Great. Next, they have an 8 in common, so all of our answers look possible. T squared plus t minus 9. Factors of 9 to give us 1 is going to be, let's see, there are none. So it is this one. So one of the kind of tricks about this lesson, I suppose, is finding out, hey, can we actually factor? And that would make sense, you know, if we're talking about the completeness of factoring, and this is our last lesson in this section. I mean, yeah, it's pretty complete that we know when we can and cannot factor. So, and if you're not sure, again, why I can't factor this, the factors of 9 will never give me 1 because it's 9 and 1, 3 and 3. That's it. Next, let's see. We got 4 terms. And if you're like, I don't remember what 4 terms is. Well, let's go back and check out the last time we had 4 terms. Last time we had 4 terms, we had to factor by grouping. And if you're like, why is this one crossed out? Remember, it didn't work the way it was written, so we had to rewrite the order. So let's go back over here. Do we like our order? Yes. Love the order. It's in standard form, and standard form should give you the fewest amount of problems. So the first group, meaning that group, has an h squared in common. So we have h plus 4. The second group, meaning that one, I'm going to factor out a negative 25. And now I have a positive h and a positive 4. So my answer is h squared minus 25. Ooh, I said my answer is, but this guy can actually factor further. He's a difference of squares. That's going to be h plus 5, h minus 5, and then that h plus 4. So let's see, which one is that? Not this one, this one. There we go. Okay, so now we want to solve. I can't remember who it was yesterday, asked a great question when we were talking about our quiz. They're like, do I need to solve these? Only if it says solve, and only if it is equal to something. So, all right. In order to solve this, we're going to have to factor it, and those guys have a k squared in common. So this is now k squared minus 100 equals 0. Well, that k squared is still going to be hanging out front, but this factors in a k plus 10, k minus 10, and it still equals 0. So the idea is that this guy, if he was 0, then the whole thing would be 0. If this was negative 10, the whole thing would be 0. And if this was 10, the whole thing would be 0. There's your answers. Solving this one, they all have a t cubed and a 2 in common. They're all even. So 2t cubed is now t squared plus t minus, let's see, is that 72? Like that. 2t cubed, that part is just going to be 0, okay? This part is t plus 9, t minus 8. If you're like, how did he do that? Eventually, you guys are going to be able to do some of these in your head of like, oh, okay, 72, yes, it's negative. We want to get positive 1. The factors of 72, I mean, there's lots, but it's 8 times 9, okay? And it's going to be a negative 8, a positive 9. So that's how I got this. This piece would be -9. This piece would be 8. And if you are, again, not sure how I got that, when will all of this equal 0? And if we were to put -9 here, -9 plus 9 is 0, and 0 times anything would be 0. So there we go. Next. This doesn't equal 0, but it could very quickly equal 0 if we subtract 16y from both sides. And we would get 4y cubed minus 7y squared minus 16y plus 28 equals 0. They don't all have something in common, but there's a group. So that group has y squared in common. This group has a -4 in common. Why -4? Because I want that piece to match this piece. And in order to do that, I'm going to factor out a negative. So I get positive 4y minus 7 now, and that equals 0. So this is what is going to factor out y squared minus 4. And these are the groups. It's going to look like that. Now, here's where this is a little tricky. This actually factors again. So if you're looking at this going, there's 1, 2, 3 answer choices, you're right. And yet I only have 2 things here. That's because this guy makes up 2 of them. Now, if you wanted to, you could solve it right here and be done, because that one's not too hard to do on its own. So I'm going to show you that and you probably already knew that that's what that factored into. But imagine you didn't. Then solving this is not that crazy. Add 4 to both sides, take the square root, and you get positive and -2, just like you would here, right? So positive 2, -2, and then this guy, if you'd like, make sure and write him down. You add y to both sides, you divide by 4, you get 7/4. Like that. Find the x-intercepts of the graph, select the solutions. This is actually quite nice. That's -5, so check. -3, check. And 0, check. That was just kind of a vocab question. Do you know that the x-intercepts and the solutions are the same thing? So there, and there. And the scale might have been a little annoying, but check it out. It's 1 blank, -2, -3, -4. So you just had to kind of pay attention to the scale there. Same thing here. Notice it's 0 blank 4. So that's got to be 2, -2, -6, -8. So there's -8, check. There's 0, check, and there's +2, check. Next, error. Describe and correct the error in factoring. So let's see. They said from this section, there's an x squared, so that's good, that's good, that's good. On this section, they said, let's take out a -9, so that's good, that's good, that's good. And let's see what's next. They take out x minus 6. They take out x squared minus 9. Okay, so if I missed the error, let's think again. So, okay, x squared is what they both have in common. And that leaves us with an x squared here and a -6. If I factor out a -9, then I would have a positive x now and a -6. Oh, okay. I think what they're getting at is this is not necessarily done. This can be factored again into that. So I think that's the answer. If you had said, no, they didn't make an error, I 100% see why you thought that, because I thought it too. A gift bag has a width W, there's the width, and is in the shape of a rectangular prism. If you're not sure what a rectangular prism is, it's a rectangle. And I know that you're thinking, well, duh, they just said that. But hang on, I'm going to show you what I mean. I'm going to duplicate that and drag it in really any direction, doesn't matter. So I'm just going to put it there. Why not? And then you just connect the corners, making it three-dimensional. And so it's just a rectangular box. That's basically what it is. That's a rectangular prism. So if you're thrown off by their terminology, there you go. So the volume of the bag is that. Well, so the volume of a rectangular prism is length times width times height. If you didn't know that, you could have looked that up. That's okay. The height is greater than the width. The height is greater than the width. What are the dimensions of the gift bag? So really, the only reason that this sentence is worth reading is that right here, it says the length, the width, and the height. Otherwise, it doesn't really matter. We're going to find W and plug it all in, okay? So how are we going to do that? Well, let's zoom out and do it. So we said the volume is that. Well, guess what? Volume is 1152. I don't know which one the width is. I'm sorry, I don't know which one the length is, and I don't care. I don't know which, I'm just going to write it all down. Length, width, height, sure, or this could be height, width, length. That's the idea there is, doesn't really matter. What we're going to have to do is multiply all this out anyway. So I'm going to go ahead and do this times this, just because I feel like it. 18 times 2W is 36W. 18 times 4 is, let's see, 32 plus 40 is 72. And then negative W times 2W is negative 2W squared. Negative W times 4 is negative 4W. And then now I'm going to multiply everything by W. I'm also going to rewrite, here, I won't take too many steps at once. And if you're like, what steps were you going to take? I was going to start rearranging it. 1152 has been there each time. Now we can combine some terms like this and this. They're like terms. So 1152 equals negative 2W cubed plus 32W squared plus 72W. Now, let's just make sure I haven't done anything wrong here, because having that negative is making me go, that feels bad. 18 and 2, that's that. 18 and 4 is that. Negative, that is that. Negative. Okay, we're good, I think. Let's keep going. We want it to equal 0, so we're going to subtract 1152. We're going to subtract 1152. Cool. 0 equals, I don't feel like rewriting it, so iPad magic. There we go. Thanks. Now, they all have a 2 in common. The entire thing does. And I'm going to factor out a negative. So this is W cubed minus 16W squared minus 36W plus, let's see, 1152 divided by 2. That's 576. Fun. Okay, now this group has a W squared in common. By the way, this negative 2 is not going to matter whatsoever, but I'm going to go ahead and keep it because you're going to ask me where it went. I'm going to do a big parenthesis just to kind of let you know all of this is about to go inside the parentheses. W squared is W minus 16. All of this has, I'm going to assume, a negative 16 in common because, I'm sorry, negative 36 because I want it to match that. So negative 36, and so that's now positive W, And here's how we can check, just real fast. 576 divided by 16. Let's see, that's 3. So 3 times 6 is 18. That's 48. So this is 9, 6. And then I'm hoping that's a 6. 6 times 6 is 36. Yep, 96. Okay, so it worked out. And if you're like, what just happened? I tried 16 instead of trying 36. If I had done 576, oh my gosh, I can't write. 576 divided by 36, I would have gotten 16. Anyway, so 16 here. I'm going to do a red parenthesis because I did a red parenthesis right here. So that negative 2 is still just hanging out there. It's not going to matter, but we have w squared minus 36 times w minus 16. Cool. So in this scenario, this is still factorable to be w plus 6, w minus 6, and then there's the w minus 16, and then there's that negative 2w just chilling out there. Here's what's about to happen. This answer is negative 6. Like, the solution with this piece is negative 6. The solution with this piece is 6. And the solution with this piece is 16. Now, here's what I'm going to do. I'm going to graph this in Desmos to kind of show you what's going on. But I'm also going to take all these answers and bring them back up here. So, is it possible to have negative 6, I've already forgotten them, 6 and 16, there we go. Too many 6s flying around. So we have a negative 6. Can I have a negative length here? No. We have a 6. Well, I could have a 6 here, but can I have a 6 here? Actually, yes I can. So let's see. If we did that, we would have dimensions of 6. Let's see, 12 plus 4 is 16, and we would have 12. Let's check it out with 16. Can I have 16 here? Yes. Can I have 16 here? I mean, apparently. 16 times 2 is 32. 32 plus 4 is 36. And then this would be 2. Now, remember earlier when I said this is important? The height is greater than the width. So here's what we just found out. It's not that. Because the height would be 2 if we used 16. Okay? So it is all of these red dimensions. So let's see, the width is 6. The length is 16 and the height is 12. You have to answer in this order. Theoretically, I know if we just pushed the box over like on its side that it wouldn't matter, but that's the idea, okay? Now, again, like I said, I'll graph this on Desmos just to show you. I don't know if it matters, but here I go. Okay, I've graphed it, and the graph is not going to be super impressive. I mean, I'll give you an idea of what the graph looks like in general. It looks like this. It crosses at negative 6, at 6, and at 16, and it basically does this. It does something like this, except that it's really stretchy. So, like, instead of it appearing to be nice and curvy like that, it's actually more like, woo, woo. It just goes crazy, so that when we look through this rectangular window, all we're seeing is like these yellow lines crossing. And you see how they look very vertical and very not impressive? That's what we're looking at right here. They're not vertical, but they look that way. So that's a real solution, real solution, real solution. It does not fit our word problem, though. It doesn't fit that. So, like, could we theoretically have a width of negative 6? Yeah, in theory, Because if you were to have a graph like this, and just for the sake of just go with me, instead of building the box in this direction, and I'm literally drawing a picture of a box right now, is what I'm getting at. Instead of going like this direction to build it, let's say that's the positive 6 direction, we'll just build it in this direction. And now that's the negative 6 direction. Does that make sense? So that's why it's possible-ish, but not in the way that it works for us. Let's move on to number 18. Factor it completely. I'm just going to assume they're being nice to us and they put things kind of in order. Let's factor out a 4b squared, and we get 2b minus a. In fact, I think they have put it in nice order for us, because look, b, ba, b, and a, and then, yeah. So this section right here, I'm going to take out a negative 9, and I get positive 2b minus a. And I wasn't asked to solve it, just to factor it. So I get 4b squared minus 9 times 2b minus a. But if you were to stop there, you'd be wrong, because this factors into 2b minus 3, 2b plus 3, 2b minus a. That is everything right there. That's the final answer. Factor this one completely. Dude, I hope, again, they're going to be nice to us. So let's just jump in here. These two have a 6m in common, so this is now m squared minus 2n. These guys have an n in common, so if I factor out an n, I get m squared minus 2n. Okay, seems all right. So I get 6m plus n. That's this piece and this piece. The rest is m squared minus 2n. And that is done because, again, we're kind of inspecting, are we really done? That can't be factored further. That can't be factored further. And if you're like, but that's squared. This is a perfect square. This is not. Last one. How can you use the factored form of the polynomial to find the x-intercepts of the function? The x-intercepts occur when y equals 0. This is just a fact about x-intercepts. Okay? So set each factor equal to 0. 0. So here let's we did that one, and solve for x. This gives the x coordinates of the x-intercepts. The y coordinates would be 0, and if you're like, are you sure it's 0, it's x and x again? Yes, because I actually went and had to check the answers, because I'm not doing the online version, so I would assume you couldn't repeat your answer, but you can. Those are all for the final answers. This, was fun. Let me know if you got any questions about factoring polynomials completely. See ya.